Awesome. Cool. Thanks for the intro. So today I'm gonna talk about composition. I think it's a superpower, and I learned a big deal about it in the last couple months and years. So I thought, like, okay, let's give back and share something. One more addition about me is that I work at serverless, and I highly encourage you to try it out because it's a really cool. I do a lot of open source, and we also have the serverless framework, which is open source, which allows you to deploy and manage infrastructure on AWS, serverless infrastructure, obviously, on AWS, Google, IBM, OpenWhisk, and Azure. Okay, but let's get right into the topic, composition. One more thing to add before. This will be quite a ride. So I will start easy with you and make it very nice. But later on, I'm going to throw a couple of terms at you. And before we get started, who of you has ever written a higher order function? Okay, a lot of people. Who of you has ever written a higher order component? Okay, less. Who of you could explain currying? Okay. Let's get less. But that's good. So actually, you're an audience worth speaking at about this topic. So let's get started. Composition. Composition on Wikipedia is defined as a mechanism to combine simple functions to build more complicated ones. Cool. That's pretty generic. So what does it mean? Well, I like to start by an example because I think that's a really, really nice way of actually explaining things. So what we're going to do is we have this list of users. There's Carl, Sarah, Ali, and Olivia. And what we're going to do is we want to apply 3 steps on this list. First of all, we're going to filter out all the users younger than 18. And I color them, so for you to follow along in an easier way. And also for me, obviously. Then we want to sort them by their age. And last but not least, we actually only want to have the names. Cool. So when we dig into composition, it says like just use a function to build use simple functions to build a more complicated ones. And you could do this with dot chaining, but there are cool libraries out there like underscore and Lodash. They actually give you a lot more tooling, and so we're gonna start right away with them. And if you use, for example, underscore Lodash, what you could do is you could, for example, filter, sort, and you can map over them. But what you have here is that you actually apply state in your function all the time. You have your filtered users, and you have your sorted users, and you apply your filtered users to the sorted users, and so on and so forth. And one problem here is that you could mess up. If you have state in between, you could easily mess up. And it's actually quite verbose. It's long. There's a lot of text here. So can we do better? Yes, of course. Underscore as well as Lodash provide you with a function called chain. And what it allows you is you basically pass in your data structure into the chain, and then you just chain along with your dot operators. Dot functions. So you can do filter, you can sort, you can use map, and that's actually more concise. That's cool. Nevertheless, there's boilerplate there because you have to use chain, and at the end you have to use value. And this is actually, like to me personally, the value part at the end. This is where I messed up a lot of times because I forgot value. I forgot to fix value, dot value in code reviews. When people made mistakes, and what we ended up was actually functions that didn't work while we thought they work. And that's, to me, that's also a little bit too much boilerplate. So can we do even better than that? Oh, by the way, and it has a couple of other issues. Like for example, if you want to extend it by yourself, like this chain list, you need to do that globally, or you always build up this new chain function if you just want to have it locally. And I highly recommend this blog post. It goes really, really deep why using chain is a mistake. Okay, so, but as we said, can we do better? Yes. What if we just filter, sort, and map? And We don't have to deal with the users in any way. We don't get the value out. We just have the overhead of a function called pipe. Well, cool. That's pretty straightforward and simple. Nice. And you can actually do this, you know? There's a library, a functional utility belt called render, and it has a pipe, and it has map, and it has sort, and it has all these useful functions. And Lodash built a functional programming version, so it's just Lodash/fp, which exactly matches the render API, and you get all these tools out of the box right away, and you have this really, really neat API out of the box. Cool. So what's happening here is that this is actually, if you go back like composition, this is function composition. And if you look at it, there's even a compose function in these libraries. What's happening is that pipe and compose are exactly the same except for the reverse arguments. So if you pipe with A, B, C, and D, you get the same result if you do compose with D, C, B, and A. Cool. Let's see this. So we just flip the arguments. The filter gets to the end by map to map, beginning in this case. Cool. Since this is a React conference, let's talk about React. Can we compose in React? This is an example that probably most of you have seen. That's from the ACAD series that Dan Abramov did. And it's an example where he starts to, where he has to connect. It's an enhancer that enhances your component, the to-do list, with the Redux store and dispatch. But he also, in this example, he enhances this one more time with router. And he does this because he actually wants to have the filters, like the filter state, which filters are to show, and he wants to get that from the parameters, from the URL. So what's happening here is that we have this to-do list, and we enhance it with connect. And the outcome, that's very interesting, is a component. So it's just like we give it a component, and the outcome is a component. And with router, coming from React Router DOM, is doing exactly the same. It takes a component, and it allows you with router to enhance the component to inject props. And that's pretty cool. Unfortunately, if you start to use this more and more, and you get you start to nest things more, it gets a little bit tedious and complicated. So let's focus on this part where we actually like wrap and wrap and wrap. Can we compose this? Yes, we can. And the best part about this, we can use the same compose function from render. One thing you have to be careful with is that while compose and pipe, like when you use pipe, it flows from top to bottom. Because of the nature how the components are constructed, you actually, to have this top to bottom flow for the props, for example, you have to use compose here. But what's interesting, so is that actually this is not only in render, it's not only in Lodash FP, it's also in Recompose, which is a library built by Andrew Clark, who gave a talk, a keynote yesterday. It's also in React Apollo. And what's fascinating is that all of these compose functions, they might be implemented in a little bit different way, but they all do exactly the same in the end. And that's really cool. So when you see this, you know, when you see something that's coming up more and more, it's probably not anymore like an implementation detail of a library. It's actually like you might figure out it could be a pattern. And that's exactly what it is. This is like compose is a mathematical pattern or technique that is backed by math. And that's really cool, and I think that's why a lot of people started to adopt it. And there's, obviously there's many more. You know, there's Connect, also React Apollo. It comes with a GraphQL enhancer. Actually, I'm gonna tell you a little bit later, but these are high order components. We're gonna get to that, to the definition, but these higher order components, they allow you to take a component and enhance it. And the cool part is that you, like, because they're higher order components, and with composition, like out of the box, you can compose them together to enhance your components to be smarter and have more features. And yeah, as I said already, you have with router from the React Router DOM. You get with state to inject state or to compose state. It's not injection actually, it's just composition. You compose it on top and you get it in the props then. And you can use Redux Connect, GraphQL, all that kind of stuff. Cool. So now you know about consumption. You know about like how to use compose, and this is definitely way more readable than if you actually rep and rep and rep and rep. So this is just a useful tool. Not too fancy, but still very helpful. All right. But since we're all software developers, I'd like to follow the philosophy that creation is always more interesting than consumption. And I think because you're developers, you're hooked by that idea as well. So let's go deeper. And actually going to show you what makes these functions and higher order components, how can you build them by yourself? So we're going to start with functions, and I'm going to start with a real-world example that was challenging for me a couple months back with Max and Brian. Brian is actually sitting back there in the room. Together we built a lightweight toolset for writing styles in JavaScript called Polished. And it has a lot of like mix-ins. For example, you have a function with a nice API and expands to CSS like a triangle, or have high DPI media queries and all that kind of stuff. But my part of this library was to create a color API, specifically for CSS. So, and very, very early on, it became like talking to Max and Brian, it became clear like we would like to make this a composable color API so that you have a set of functions, but like color functions are, we can provide a couple of simple ones, but you should be able to create more advanced ones by yourself. So the goal that we set out was provide a set of composable color functions. How does this look like? For example, pastelize. Like, I think pastel colors are pretty cool, so I wanted to build a pastelize function. And the idea for the API was you should be able to use any compose, maybe from Ramda, Lodash-FP, or even like recompose, and just use tint, like to tint the color a bit, to lighten it up, and saturate. Cool. And how this would look like is that you get out a pastelize function, and then you can just provide any kind of function, any kind of CSS string color, and you get out the new color function. Cool. On this path, by actually like, now we have the API set out. On this path, I figured out there's 3 things that we need. You could say they are constraints. I actually would rather call them requirements that needed to happen to make your API composable. And first of all, what we figured out is every function must accept and return a CSS color string. This is very important. So, for example, toCSS or toString was not an option. We could have done this like that. Every time you darken, for example, you do .css, .toCSS or toString, but then you have to put it into compose as well, and that would end up being like having like a dot value again that we know from this chain example. And that was clearly not the goal. Like, the goal was to make a really nice API that's really, really usable for you. So that was the first requirement. Cool. Now I'm gonna build up a little bit to tell you what the second requirement was. So when you look at it, like, it was clearly stated that it should not only be composable on our side internally, but it also, like, you should be able to use it in a simple way as well. Like, just provide the amount you want to lighten by, and then provide the function, the CSS string, and then you can take the output, which is just the CSS color string again, and you could saturate it, for example. And what you get out is a new color. But still, we also wanted to have this composable API, where you could simply, like, this would exactly do the same, you know, you compose and you compose, lighten, and saturate. But what was interesting is when you looked at the function signature, suddenly the color was not there anymore. It was just the amount. And that led us to the second requirement. A color function accepts all arguments except the last and returns a function that accepts the color as an argument. So basically, you provide the amount or all the arguments that you have to give it before, and then it actually should return a function. It should kind of lock in the parameters, and then you actually get back this function where you just apply the color. Cool. So what this would be is lighten 0.3. I lock in the parameter, and then I actually can provide the color. Well, that would be interesting if you could use it like this, but it wasn't the same signature as this. And while this is a very functional style, we are still in JavaScript, and in the end, a list of a couple of arguments this is what people are used to, and this is actually by design how you should use the language. This feature is not there for nothing. So this was a problem, because basically we wanted to support two different signatures. We wanted to support the signature of provide two arguments or only one, and then return a function for that. At first I thought oh my god, this will be a problem. But then I learned it took me some time, and then I okay, let's give it a try, because Ramda and Lodash FP, they actually do exactly the same. You know, they allow you to give a data structure, and for example, if you do map, you can get the data the function itself, what map should do, and then the data structure, but you only can provide also only the function, and that's this signature, and then afterwards provide the data structure. So let's look at our lighten function. How would we need to change it? I don't want to go into that part, but I just want to tell you to make this API, both API signatures possible, suddenly we had to change from this to this, and this was really, really bad, because this induced a lot of complexity, and this basically also heavily, if you need to do that for every function, for every color function, that would significantly increase the code size, and that's really, really bad. Luckily, there is currying, you know? So what you can do is you can basically take any function that, for example, takes multiple arguments, and you can curry it, which exactly gives you this. What we did here manually, that we decided if color is not provided, and then we return a function, or if color is provided, we actually apply it right away. What happened here is curry does that for us. It's one smart function to do that for us all the time. Cool. And because we didn't want to that the users should do that by themselves, we actually built it into the library. So we have for example, now all the color functions. This is lighten, and then what we actually return is the curried version of lighten, because it accepts both signatures. Cool. So now you learned about currying. So currying, just as a reminder, currying is the technique, and this is Wikipedia. Currying is the technique of translating the evaluation of a function that takes multiple arguments into evaluating a sequence of functions. So multiple arguments, sequence of functions. Cool. That's good. So now we learned something. Currying. Pretty cool. All right. Just as a reminder, this is what currying looks like if I do it on a range example. This is just for because I said creation is always more valuable than consumption. I don't want to go into that because of time, but this is actually how a full, this is one implementation of a curry function. So this is not some crazy magic that's going on there. This is just a recursive function that's going in and taking one argument and figuring out based on the argument's length, it slices it. And so it's not magic. It's something that if you take 15 to 20 minutes, you can understand what's going on here. And this is functional programming paradigms. That's cool. One thing that we also actually learned on the way we learned about higher order functions. So if you're one of the few people that haven't written a higher order function, like a higher order function, like by definition, is a function that does at least one of the following: takes one or more functions as arguments, or returns a function as it results. And if you think back about the example that we did manually, like when you apply this, this is actually a higher order function. Like it gets the amount and returns a function that takes just the color to apply it. Cool. So, and the best part about this, the future is really, really bright, because there's cool languages that are like heavy in development, like ReasonML, and they do this by default. Like these paradigms in these functional programming languages, they're in there by default. Like if I define a function, for example, in ReasonML that takes 3 arguments and you concatenate them, like what you get out is actually a current function. You cannot work around it. That's like, it's built into the language. And the same goes for Elm. Elm even takes it, while it's pretty simple to write a compose function, but Elm takes it even a little bit further because they have an operator to compose. It's built into the language. So these techniques are like so deep into functional programming that people functional programming creators, they actually built it into the language. And this is our pastoralized function, for example, in Elm. Looks pretty neat as well. Cool. I said there are 3 requirements. So let's dig into the last one, because this is actually the most simple one, but it was quite mind-blowing. So the argument to be modified, or the data structure to be modified, must be the last argument. That was interesting to me, because I figured out, like, if I do this signature, we have the color first and the amount second, I can't lock in the amount. I actually have to make the amount first to make it composable. So I have to make the amount first, and then whatever I want to modify, I want to compose, then that has to be last. And like only after like building all that kind of stuff, I really, really realized like how important it was. And if you look, for example, at the signature of underscore and Lodash, the normal version, like the first argument is the data structure, and then you provide the function, for example, for map. But if you look at the functional programming version of Lodash or render, it's actually just reversed. And that was very interesting, because to me, like, this always felt a little bit strange until I started to realize that this is actually for a purpose. This is for the purpose to make composition possible. And this was such a aha moment that, like, it was not only that like, until then, I've always thought like the argument order is just something arbitrary that I can choose, and it's like, it's not that important. And it's like just for a user experience. But what I realized that day is that actually the argument order has a huge impact on the functionality that's possible for your API. So you better think about it. Cool. So that's the end of the functions part, you know? We have compose of functions. And that's all the stuff that we needed to do to make our API composable. Quite a lot, but I think it's definitely worth it, because you can do cool things like that. All right, back to React conference. So you remember that guy? Like compose, and you have like these enhancers here. So how can we actually build such an enhancer for ourselves? Well, the signature, let's look at the signature first, is actually pretty simple. You know, it takes a component, and the outcome is a component. This is what the signature of these enhancers look like. So, and you might have seen this here. This is like double error stuff, and when it gets really, really complicated, you bail out. At least I do. But it's like, if you look at it from this perspective, you know, a component can either be just like a function that accepts props and then returns JSX. that makes everything like suddenly like, okay, I get that. Obviously, a component can also be a class. So you can do this as well. You can simply just return a full class. And this is what we call higher order component then. This is just like a function that takes a component and returns a component. Cool. So if this was a little bit too steep, let's take a real world example. In my case, we need a loading indicator on every page that fetches data with GraphQL. So what we had before, for example, the profile page, and we had here the GraphQL. It's coming from Apollo, the GraphQL higher order component that gets a query and then wraps this existing component. And it was injecting data into props and then the real data as well as loading. But the thing is, what I learned after doing a couple of them is that this props data.loading, this was like a repetition that came across multiple times, like actually all the time. Every time I did a component, you needed some kind of loading state. So this part, compared to like the project page and the profile page, this was repetition. Well, cool. So what can we do with repetition? We can extract it. Awesome. So let's build a higher order component. Pretty straightforward. We have our with loading indicator. It takes a component and it gets props, which is the component, and we simply return JSX. You don't have to return the component that you actually get, because you can return anything. You just have to return JSX and it's valid. That's the only thing. It takes a component and returns a component. It doesn't matter if you actually render or return the component that you got. So what you can do with this is, like, we now have a with loading indicator, higher order component. So what's happening here is that, like, if loading is there, we're gonna render just loading div. But if loading is false, then we render the full component with all the props that we just pipe through. And the outcome is, if you look at the profile page, our view component got significantly simpler, and the whole thing has way less lines of code, and we extracted this loading indicator into the higher order component. We just compose it into our profile page. And that's where we go back to composition. Because when you have composition, all that stuff makes actually sense, and it's way, way easier to deal with. That's really, really neat. Cool. But you don't have to stop there. You can also, like, you probably don't handle errors too much, or at least I do. So the way I deal with this is I just built myself a with error message component, a high order component that just put into every GraphQL. I compose into every component that uses the GraphQL high order component. And this is a really neat way of actually dealing with that problem. Because you only have to make sure that with error message works once, and you can test it, and then you just compose it in, and it works. Cool. So, but the world is it's always like you have this one boss that needs one more feature request. And so what about if we need a custom loading text for every page? We actually can make this happen as well. You know, higher order components. We can make sure it's a function that returns a higher order component. So what we can do is we can actually take, inject here this function, and this is where it gets really weird, error, error, error. But still, once you comprehend that once, it's actually a really powerful tool. So we just inject the text here. And what the usage of this then changes to with loading indicator to show loading profile and actually pass in the text. And that's a cool, powerful concept. Cool. So higher order components, just as a reminder, a higher order component is a function that takes a component and returns a new component. Pretty cool. Awesome. So let's get to the really, really cool stuff. React VR. Does this? No. Oh, yeah. Now it spins. So I really enjoy React VR. It's super fun. And I built this Earth that's spinning. It's an infinite rotation. And this is the whole component. The thing is, it uses the animation API. It uses exactly, if you're familiar with the React Native animation API, then this is exactly using the same. And you probably can't read this, but the point here of this slide is that everything is green, that is just the globe, the Earth, with the texture and so on. And everything that's violet here is actually just the code for this infinite running animation. And you can see this is a lot of code just to get the animation done. But what happened here is, and this is a really interesting use case, is I not only had Earth, but I had in my React VR scene, I had multiple planets, you know? So I had this one and this one on top. And all of them needed this infinite rotation, because planets just rotate, you know? So what can we do? It's like, this is a perfect use case where I can actually make a higher order component. Can you remember this here? This is a bunch of code, and we can extract the whole rotation part and actually get it into one higher order component. And we can even provide it with parameters, as we've seen with the text before. And that's really, really cool, because suddenly, you can have this higher order component, you can test it really well, and you can do multiple planets that are actually way, way simpler in your code base. And that's pretty cool. All right, so should you use higher order components all the time now? No, obviously not, you know? A chainsaw is not the best tool to hit a nail. You rather use a hammer. So I want to quote the React docs here. Keep in mind, components are the primary unit of code reuse in React. However, you will find that some patterns aren't straightforward, fit for transitional components. And I think this rotation part is a perfect use case. With loading, it's a perfect use case. So what they're always like cross-cutting concerns. These are concerns that you need for multiple components, but you don't want to wrap them. Sometimes you can't even, but you can enhance your component with. And so that's it. Congratulations. You actually learned about high-order functions, currying. You got a badge for high-order components, and finally compose. And that's it from my side. Thank you very much.